All right, so we're going to be continuing our lesson on 3-1. If you haven't seen part 1, go ahead and pause this video and try that one first. So we're going to move on to number 3. And so in this one, they're asking a lot more questions. So they are no longer asking about the origin, although I threw that in there just for a little more practice. But they are asking about the x-axis, the y-axis, the line y equal x, and the line y equal negative x. And if it's none of those, we would say none of these. All right, so we have the equation x plus y is equal to 6, and then we're going to put in our control. So our control is going to be x is equal to a, y is equal to b, and that's equal to 6. So any of these equations that I can get to match this one here is going to allow me to understand that the graph is symmetric with respect to that thing. So substituting here, we get negative a plus negative b is equal to 6, substituting that into this equation right here. Okay, so I notice these a's and b's are positive, these are negative, so I'm going to go ahead and multiply everybody through by -1. And so if I distribute that, I get a plus b is equal to -6. And so do you see that there's no way to make it exactly the same as that blue one? So we're going to say no, it is not symmetric with respect to the origin. So then looking at the x-axis, I'm going to let x be a, I'm going to let y be negative b, and it's equal to 6, again substituting back into the original. And so simplifying, that's a minus b is equal to 6. Now, if I tried to multiply through by a negative, then the a and the 6 would be negative. So there's no way to get all three of them to be positive at the same time. So this is another no. It's not going to be symmetric with respect to the x-axis. So then if we consider the y-axis, that means the x changes. So that's going to be negative a plus b is equal to 6. And again, even if I tried to multiply through by a negative, I could never get everybody to be positive at the same time. So I cannot get it to match that blue equation. And so this one is a no as well. So this one says use b for x and use a for y. And then we know that we have the commutative property of addition that says that that's the same as a plus b. And so notice we got the two equations to match. And so that means that we are symmetric with respect to the line y equal x. And then coming over here, if I substitute negative b for x and I substitute negative a for y, I would end up with negative a minus b equal to 6. And again, even if I multiplied through by a negative, I couldn't get them all to be positive at the same time. So this one is no. And so this is not true. So we would say the only thing it's symmetric to is the line y equal x. So if we take a look at Desmos, I have this graphed for us. So that is the line x plus y is equal to 6. And so if I check a couple things, so if we want to be symmetric with respect to the x-axis, that means that we should be able to fold it along y equals 0 and have it lay on top of itself. So do you see that if we folded this along that blue line, it would not lay on top of itself? And if we wanted to check the y-axis, we would check the line x equals 0, not O, there we go, and that's this black line right here. And again, if I folded along that black line, the green line would not lay on top of itself. If I want to check the line y equal x, this one should work. So do you see that if we folded the paper along this red line, the green line would lay on top of itself? So it should be symmetric with respect to the line y equal x. And then if I add in this negative here, do you see they're parallel to each other? So if I folded along the red, the green would flip all the way across the red and it would not lay on top of itself. So the only one it was symmetric to was the line y equal x. All right, for our next equation, we have the equation x times y is equal to 3. And so this is what we're going to be substituting each time. So this is our control. So we're saying x is equal to a, y is equal to b, and the equation said that their product is equal to 3. So this is what we're going to be comparing to each time. So if I substitute negative a for x and I substitute negative b for y, I want to see if I can get them to match. So a negative times a negative is a positive. So I can say that's equivalent to saying a times b is equal to 3. So because that matches my control, I can say we are symmetric with respect to the origin. So again, if I traced it on patty paper and rotated it 180 degrees about the origin, it would land on top of itself. So then the next one, trying the x-axis, I could substitute a for x and negative b for y. And a positive times a negative is a negative. So that gives me negative AB is equal to 3. So even if I multiplied through by -1, there's no way to get both sides to be positive. So this one is a no. So we are not symmetric with respect to the x-axis. So looking at the next one, if I substitute negative A for x and positive B for y, we would get the same equation, negative A times B equal to 3. And again, there's no way to multiply or manipulate that to get both sides to be positive. So that is a no. It's not going to be symmetric with respect to that line. Then if I plug in B comma A, I would get B for x and A for y equal to 3. And we have the commutative property of multiplication that says we can switch those around and say AB is equal to 3. So if you notice, this matches the control, and so we are symmetric with respect to the line y equal x. And then finally, I can substitute negative b for x and negative a for y and see if that's equal to 3. Negative times a negative is a positive, and it doesn't matter if I say b times a or a times b. So we get a times b is equal to 3. And so it is symmetric with respect to that line as well. So we would say origin, we would say the line y equal x, and we would say the line y equals negative x. And so then let's take a look at Desmos and see if it agrees with us. So I went ahead and graphed x times y is equal to 3. And so then there's no way to test the origin. Just think of tracing paper and rotating it around. But the x-axis would be the line y equals 0. And do you see that if we fold that graph along that blue line, it will not lie on top of itself, that the green in the first quadrant would land in the fourth quadrant, and the green in the third quadrant would land in the second quadrant. So it is not symmetric with respect to that line. So if I do x equals 0, that's the y-axis. Again, the green would land in the wrong quadrant, so it wouldn't lie right on top of itself. But if I add in the line y equal x, oh, they're both green. That's lovely. So if I folded my graph along this darker green line, do you see then the graph would lay right on top of itself? So it is symmetric with respect to the line y equal x. And similarly, if I folded along the perpendicular, which is the line y equal negative x, it would lay right on top of itself. So we are symmetric with respect to the line y equal negative x. All right, so this would be a good time for you to pause the video and see if you can do this final example and determine if it's symmetric with respect to which of these 5 things. So pause it and go ahead and get started. All right, so I'm going to go ahead and substitute my control in here. So I've got my y value is b and my x value is a, and I want to see if I can get things to look exactly like this, that b is equal to a squared minus 1. So if we try the origin, that means that I'm going to have negative b is equal to negative a squared minus 1. So a negative times a negative is a positive. So this means that I have negative b is equal to, and we get positive a squared minus 1. So here's the thing. If I even multiply through, because I've got my right-hand side looking good, but my left-hand side is the opposite, and if I multiply through by a -1, I'm going to change this to the opposite. So there's no way to make this look like my control, and so we're going to say no, it is not symmetric with respect to the origin. So then if I test the x-axis, I'm going to substitute negative b for my y, and I'm going to substitute a for my x. And again, I get that same equation. And if I tried to multiply both sides by -1, it would mess up the right-hand side and nothing would be equivalent to that blue. And so it is not symmetric with respect to the x-axis either. So then if I try the y-axis, I've got b is equal to negative a squared minus 1, substituting b for y, and negative a for x. And we said that a negative to a second power is a positive, so b is equal to a squared minus 1. And just like that, we got it to look just like the blue equation. So we are symmetric with respect to the y-axis. Substituting this one, we're going to substitute b for x and a for y. So that means a is equal to b squared minus 1. Now, even if I tried to manipulate the negatives and all that stuff, do you notice that my b is squared here? And it's a that is squared in my original. And so there's no way to get that to change places. So this one is going to be a no. And it's not symmetric with respect to that line. And then similarly here, the a is going to be substituted for y, and the negative b is going to be substituted for the x, and then we have minus 1. And so that simplifies to negative a is equal to positive b squared minus 1. And again, the b is being squared, whereas in my original, the a is squared. So this is also a no. So this one is only symmetric with respect to the y-axis. And so if we take a look at Desmos, we've got this green graph here. So again, there's no way to graphically talk about the origin, only because it's kind of a patty paper thing. But we could see that if I rotated that parabola 180 degrees, it would not fall on top of itself. So then if we try the x-axis, that's where y is equal to 0. If I fold it on that blue or purple line right here, it would not lay on top of itself. So if I try x equal to 0, which is the y-axis, folding along this purple line, the parabola would fall on top of itself, and so we are symmetric with respect to the y-axis. If we tried the line y equal x, if I folded along this diagonal line, the parabola would not lie on top of itself. And if I change that to negative x, it also would not fall on top of itself, folding it along this blue line. So coming back to our work, we would just say that it is symmetric with respect to the y-axis. So again, this is helping us figure out how to graph things quicker than trying to plug things into the XY chart.